Welcome back, everyone. I hope you're doing well today. So, congratulations to making it almost through chapter 4. We are now at the final concept and technique that we will talk about in this chapter with regards to solutions, specifically titrations. So, titration is really a workhorse in terms of a technique that chemists use to determine concentration. If you go on in chemistry, you will do many more titrations. Not only in this class, but in Chem 2. And if you go on to take analytical chemistry, titration is really it's a fancy word to specify the method of determining or standardizing a solution, specifically its concentration, by measuring the volume of solution in comparison to a known amount of compound. The known amount of that compound is called a primary standard, and the solution that you are standardizing is called the analyte. Many times, if you are standardizing an analyte that is in the burette, and that's what this long skinny tube is, it's called a burette, that solution is also called the titrant. So let's talk a little, in this video, we're going to talk a little bit about the terms associated with titration and how to set up a titration. We'll talk more about titrations in actual lab when we are face to face. In the final video for this chapter, we'll talk about how to set up and solve titration word problems. But let's talk a little bit about some of the parts of a titration apparatus. So in a titration, the volume of solution that you are standardizing or trying to determine is placed in this long, big, skinny glass tube that is called a burette. A burette has graduations on it, much more precise than a volumetric flask or a graduated cylinder. Most burettes can be read to the 100th milliliter. So the volume of the solution that you are trying to determine is placed in the burette. You can control the volume of analyte or titrant by the stopcock. What is in the stopcock is right here. What is in the flask underneath the burette is where the primary standard is, or the known amount of compound. And how a titration works is you have a known amount of compound, an unknown concentration of titrant, and you're going to react them in this flask. And once you reach something that's called the end point, then you will be able to do calculations with regards to moles and volume of the liquid in the burette. And so maybe thinking, okay, well, that's great. How do I know when to stop adding amount of titrant to my flask? That is where an indicator comes into play. If you go on in chemistry, you'll learn about lots of different indicators, but an indicator generally is a chemical that is added to your reaction flask, and that indicator will change color once you have equal moles of titrant and primary standard in your reaction flask. And once you know that, and so once you get a color change, that tells you, oh, I've got equal moles. I can stop the titration and do calculations. So the primary titrations you guys will be doing in this class and also in Chem 2, if you go on to Chem 2, are acid-base titrations, where the reaction that you are making use of in your titration experiment is between an acid and a base. And primarily the base solution is in the burette, and the acid solution is in your flask. And the indicator that is used in most strong acid-base reactions is called phenolphthalein. It's kind of a tongue twister. But what's nice about phenolphthalein is that when added to an acid, it is clear. It turns pink or turns the solution pink once that solution becomes basic. Basic enough where that it tells the chemist or the scientist that there are equal moles of acid and base in the flask. So many times titrations are done, specifically acid-base titrations are done, where you have your base, in this case, it's sodium hydroxide in your burette, a known amount of acid, in this case tartaric acid, along with phenolphthalein. And before you start the titration, the solution color of that tartaric acid and phenolphthalein is clear. Then you start to gently add your base to your acid indicator solution. And you want to be able to determine moles of base of your sample. And you can determine that by the color change of the indicator. So the indicator will change pink, telling you that, oh, okay, I've got equal moles of acid and equal moles of base in my reaction flask. And since I set up my titration, so I know I weighed out exactly how many grams of tartaric acid I have, I can calculate how many moles that was. And that number of moles of tartaric acid will equal the amount of moles of the sodium hydroxide. So that sweet spot, that point where you have equal moles of acid and equal moles of base in your reaction flask, in your, in this case, Erlenmeyer flask, that sweet spot is called the equivalence point. That means you have equal moles of acid and equal moles of base in your flask. And that can be used to do calculations. So that's sort of the setup for titrations and some of the terms that are used, particularly with acid-base titrations. Those are the kind you'll be doing in this course. In the next video, which is the last video for Chapter 4, we're going to talk about how to use data from an acid-base titration to do calculations with regards to concentration of the titrant.